and I'm going to have you guys make sure that you have this, that r is equal to 2 v naught squared sine theta cosine theta over g. Okay? So what's 2 sine theta cosine theta? Anybody know their trig? What is it? Sine 2 theta. It's a double angle, right? Identity. So sine 2 theta. So that makes this even simpler. It's just r is equal to what? V naught squared over g sine 2 theta. Right? So all I need to know, and this is very nice, right? All I need to know is that if I can break the velocity down into its components, because I've already solved for time, I'm really getting like x in terms of y and y in terms of x, and makes this very solvable with minimal initial conditions. Okay? If you go back a couple of equations, if you knew the time for some reason, but you didn't know some other things, you might be able to use some of those very easily. In this situation, if you can find if you know the initial velocity and you know how to use a little bit of trig, you know exactly how far this thing went. Okay? Which is very helpful. So now a really important question. To get a maximum R, R max occurs at what angle? At what? 90 degrees, 45 degrees. Which is it? Okay, great. So I noticed that it had this sine 2 theta in it. Right? If it had sine 2 theta, then theta at 45 makes the sine of 90, right? So at 45 degrees, this is sine of 90, which is 1, the maximum of the function. Okay? So at that point, this thing is just v naught squared over g. Right? G. That's my maximum range. If we want to look at this again, down here I've got an equation for the maximum range of a projectile. So you should definitely know that and understand where it came from. Okay? If I go back a little bit, how do I go back slide to slide on this thing? We can look at a simple problem. And maybe a more complicated one, but let's just start with the easiest situation. So, Matt Wysocki is a soccer player, okay? And he kicks the ball so that it has an initial velocity of 20 meters per second. That might be a little quick. 20 meters per second at an angle of 38 degrees. Okay? Nothing pretty. You should all have calculators with you, right? Right. So barring any air resistance, and assuming that this ball was kicked on Earth, I want to know how far it goes.
Oh yeah, we're going to learn about air resistance.
Yes, you are going to learn about air resistance in a little while. But right now, you're going to solve this as though air resistance were negligible. So, how do I start this? V naught x and V naught y? Okay. So what's V naught in the x direction and V naught in the y direction? V naught x is what? Right.
That velocity constant, or it's not going to be.
20 meters per second times cosine of 38, which I can't really squeeze in there, so sorry. And then y is v naught sine theta is equal to 20 meters per second times the sine of 38 degrees, right? So v naught x is equal to and v naught y is equal to. Can somebody tell me what those are? 15.76 meters per second. And v naught y? 12.31 meters per second. Okay. So let's do this. What's the time of flight? What do I mean by that? What do I mean by that? Somebody take a guess. Give me something. Time of flight.
Alright, so how long is travel?
How long it's going to be in the air, right? How might I do that?
We take x minus x naught, and then we do
Okay, well, yeah, if I want to know the time of flight, it's really only dependent on one velocity, isn't it?
Yeah.
Which, the y component, correct? So I can really just imagine that I threw the thing straight up and then it came straight down. So there's a simple kinematic equation to do that. Y minus y naught is what? 0, because I start at one height and I end at the same height in this instance, correct? Okay, so if y minus y naught is equal to what though? And go back to that basic kinematic equation that says v naught t plus 1/2 at squared, right? But v naught in this instance is v naught y times t minus 1/2 gt squared, right? Can I use that? Huh? Yes, I can. Y minus y naught is 0, right? Which means v naught y t is equal to 1/2 g t squared, right? Yes? Okay, so I can get rid of some guys here. When we get back to that equation, t is equal to what? 2 v naught y? What? 2 v naught y over g. Right? So somebody give me a solution. 2 v naught y was 12.31 meters per second. So I've got 24.62 meters per second divided by 9.8 meters per second squared. It's going to give me something that comes out in seconds, right?
51,
What is it? 2.51 seconds. 2.5 seconds.